Hi guys, welcome to another Maths Corner video. And in this video we're going to be looking at different types of factorials. Things get really rather interesting, particularly when we come up to the fourth one. But for now, let's have a look at the standard factorial, and then you get to see exactly where it all leads to. So we'll do 5 factorial first. And the way to work that out is you start with 5 and then you multiply all the sequences and you multiply all the numbers, but going down in the sequence for every exclamation mark you see. So you've got then 5 times 4 times 3 times 2 times 1. 5 times 4 is 20, times up by 3 is 60, times up by 2 is 120. You can just ignore the 1 because it gives you the same answer, 120. So we'll quickly put that down. Use black for this one this time. So there's your first answer of the standard factorial. We also, let me just bring this a bit closer. Bear me 1 moment. I can't do anything while I'm recording. Never mind. Let me just. There we go, I think that's the best I can do. Okay, so the next thing we want to look at is a double factorial, where you see 2 exclamation marks after a number. So we've got 9 double factorial, but before we do that, let me just do a standard factorial of 9, and then you get to see what happens when you do a double. So you've got 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, in an earlier video you did see me work this out. And this is what your answer is when you do 9 with a standard factorial. But then when you look at a 9 double factorial, instead of taking the sequence down by 1 each time, you're going down by 2. Which then ultimately makes the number a lot smaller. So you've then got 9 times 7 times 5 times 3 times 1. Now you can ignore the 1 in this because it won't contribute anything to the sum. But at least it's there. Now, interestingly enough, that's an odd double factorial. If you're looking for an even, say for example 10. Say for example a 10 double factorial, you get the following. So you do 10 times 8 times 6 times 4 times 2. Now 2 times 4 is 8, times the 6 is 48. 48 times 8 is 392. no. 8 times 6 is 48, 192, 384 is your 8 double factorial, and then what you do after that, for 10, just do that. But we're looking for 9 double factorial. So 1 times 3 is 3. Times that by 5 for 15. Times that by 7 for 105. And your answer would be 945. Now you can see at this point that the number is a lot smaller when you do a double factorial than what it would have been if you do just a standard. So 945 would be your answer there. So I'll put that in. Now, on the third one, where we're looking at a triple factorial, this is where things might get a bit difficult. So not even my scientific calculator would work at 2 1. The only time you can ever do a factorial on a scientific calculator is if you do a normal one. So I've tried it with doubles and triples, and you get errors every time. Well, I certainly did. So anyway, 14 triple factorial is you start at 14 and then you go down in a sequence of 3 each time. So you've got 14 times 11 times 8 times 5 times 2. Now, the 5 times 2 is 10, which will be important in a bit. So 14 times 11 is 154. 154 times 8, I think I'd better try and work this one out. So 154 times 8. So then you've got, that's 32. 5 times 8 is 40, add 3. And then 1 times 8 is 8, and then add 4. And then just remember, as I mentioned earlier, that 5 times 2 equals 10, because then what you do is you then just stick that on the end, and that's your 5 and your 2 sorted out in one step. That's if you've got something like a 8 triple factorial, 11 or 14, because you then get to work out the 5 times 2 together to give you 10. It's an interesting little shortcut there. It only works if you've got that. It only works though if you're in that situation, so please be careful when you do little shortcuts. Put the answer up there. The fourth one is where things get interesting. Now, a primorial, I'm not even saying that correctly either, but there we are. We're learning. But primorial is denoted by a hash sign next to your number. So let's go for 7. It's the first number that came to my mind when I was thinking of a prime number. And then what you do, let me turn that into an equals. What you do here is you multiply that number by any prime numbers that you've got. by any prime numbers leading up to it or leading away from it. So a prime number, as I mentioned earlier in an earlier video, a prime number is a number that can only be divided wholly by itself and 1. So what we've got there, 2 is a prime number, so is 3. 4 isn't, nor is any other even number after 2. 5 is, and 7 is, and 7's the last prime number at that point. So with that in mind, you do 7 times 5 times 3 times 2. And then we've got then 7 times 5 is 35. Put that there. Times that by the 3 then becomes 105, 210 when you do the 2. It's interesting it's an interesting world of maths that we live in. And it can also get very complicated as well if you're not careful. Next thing we want to look at, sorry if I'm typing a lot. Next thing we want to look at is what we call super and hyperfactorials. Now, a superfactorial, if I give you an example, let's do a 6. 6 superfactorial. You've then got, normally with a standard factorial, I'm going to have to move that down a bit, because otherwise I'm going to overwrite what I've already got. So normally, when you're working out a factorial, a standard factorial, you are just multiplying the whole integers leading up to it or leading away from it, whichever way you wish, because you get the same answer regardless of how you do it. But this time, what you're doing, this is what you normally would expect to do in a normal factorial, but when you're doing a superfactorial, you're multiplying the factorials in the number and not just the integers. Now, so far, leading up to the superfactorial, if you've got any type of factorial with a 0, by default, your answer is going to be 1. It's just, that's the way it is. It's always been that way, because there's only the one way to do it, and that's absolutely nothing. So with that, it's always going to be 1. 0 factorial is always going to be 1. It's also the same answer you get if you raise anything to the power of 0, but I digress. So anyway, what we've got here is we're working out the factorials of each number. So 6 factorial is 720. This is where things get complicated really quickly. 120 is your 5, 4 factorial is 24, 3 factorial is 6, and obviously 2 and 1. Now 1 times 2 is 6, 1 times 2 is 2, times 6 is 12. Do ignore me on that. 1 times 2 is 2, times 6 is 12. 12 times 24 is 288. Now 288 times 120, this is where I need to start working stuff out. And then what I'll do is I'll use a calculator after I've worked it out. So everything with a 0 will be 0. So I'm just going to put a 0 here. And 8 times 2 is 16. Again, 8 times 2 is 16, but this time we go add 1. And 2 times 2 is 4, add 1. And that is 288 times 20. And then what we do is we will go for that. That is and 2. Now I've got to be careful with this one. So that's always going to be 60. And add them straight down. So 8 plus 7 is 5. 13, add 1. And 2, add 1. That's where I went wrong last time, add 1. Because otherwise you'll end up overshooting. So that's the answer I've written. Let me check it on the calculator just to double check. And I've got it right this time. Tried it earlier, and because I forgot to carry the 1 over, I was out by 10,000. I was 10,000 under. So always remember to carry numbers over where it's absolutely necessary, because otherwise you could end up running into problems. Particularly if you go higher than 6. Now, that one so far has been the fastest growing out of the 5 that we've done so far. The next one we want to look at is a hyperfactorial, which at this point, what that does, one thing I forgot to do, that's only up to 5. I need to do 6. 34,000. Yeah, I've just only remembered that's only 5. I need to do 6. Right, let's get rid of those zeros. I need to just remember to add them in later at the very end. So we'll do 3,456 times 72. And then you've got 12. I suddenly forgot that was only 5. And then you've got 10 plus 1. 4 times 2 is 8, add 1. And 6. And we do that as well. 42. We'll get to see where I've gone wrong. That's 42. 35, add 4. It's 39. 28 plus 3. Right. Yeah, 39. 4 times 7 is 28, add 3. 31. 21, add 3. Add them straight down. Just remember to add 2 zeros, and the rest is hunky-dory. So I think that's 18. 6 plus 1 is 7, add 1. And I carried 1 over when I shouldn't have done. That was my mistake. So now we'll do that. And now hopefully you should be able to find the right answer. So that's what I've written down. And there's the answer. There, I've got it right this time. So I don't need a calculator for this bit, because we're going to be doing what's called a subfactorial. Let me write down this answer first. This one's the fastest of the lot. We've got two more after this. Put 3 down, it's 2 for 2. So we've got then the following. That is 6 superfactorial. So now we're going to go hyperfactorial. This time we're only going to do 4 hyperfactorials, because what this does is you're multiplying numbers raised to the power of itself. And it's symbolised by an H and a number inside the brackets. So what you're doing here is you're doing 4 to the power of 4 times 3 cubed times 2 squared times 1. So we've got 4 to the power of 4, which is 4 squared is 16. So you're multiplying the same number by itself 4 times. 3 times. So you've got 4 times 4 is 16. That's squared. 64 for cubed, and then 256. So that's the 4. And 3 cubed is 27. I think I'm going to have to work that one out. So that is 42, 35, 35, add 4. That's 42, 35, add 4, 14, add, yeah, 42, 35, add 4, 14, add 3. That's 256 times 7. And then you've got that. That's 2, that's 11, 8, 9, because you need to carry one over. Yeah. So that's 6,912. Let me double check that. That's the answer I've written down. Yeah, it's 6,912. And then to do that, 6,912 we're up to, and that's doing 4 and 3. And then what we do is 2 squared, which is 4, which I think I'm going to have to work that out as well. 8, 4, 18, 24, add 1. It's 8, 4, 18, 24, add 1. Let me double check that. So that's the answer I've written down. But I'm completely wrong. Right, where have I gone wrong? Let me double check. 6 times 4, 2 times 4 is 8. 4. 9 times 4 is 36. And 6 times 4 is 24. Add 3. That's more like it. Sorry about that, guys. I've never done hyperfactorials before, so I'm still learning. Good thing about these videos, it's a good thing with these videos, you get to learn as you go. Now these numbers, good job I stopped at 4, because you can imagine what would have happened if I did that as 6. If I got it wrong at 4, you can imagine what it'd be like at 6. Now, a subfactorial is you're taking items in a list and you're getting rid of the bits that are in the similar positions. So what we've got, because I'm going to do a 3 for this, a factorial essentially is a way of showing you how many times you can arrange a list of items. So for example, with a 3, you can do A, B, C. Or even better still, because this is maths, let's do numbers. So you can go 1, 2, 3. But then you can also have, in this case, 1, 3, 2. And then you can do 2, 1, 3. And you can do 2, 3, 1. And then you've got then 3, 1, 2, and 3, 2, 1. So this is how you get the factorial of an answer, because that tells you how many times you can sort items out, how many times you can rearrange items in a list. So what we want to do now is do subfactorials. So let's get rid of that 1 and put it there, and then cross that one up because they're in the same position. There's a 2 that we want to get rid of as well. My black's running out. Let me swap my blacks. I need to throw that away. Don't need a calculator for this one. So we do that. We'll get rid of that, and then we can get rid of that as well. And then the 3 is that. And then what we do is we can then disregard anything that I've got crossed out, which are those top 2, because we've got something crossed out there, and that one there as well, and the bottom one as well, which then leaves you with those 2 items. So then giving you the correct answer for 3 subfactorial 3, giving you the answer of 2. Because then all you've got left over are those ones, and they don't appear as a duplicate in the same position anywhere in the list. Going back to doing the 1, 2, 3, if we put the 1, 2, 3 back into the picture, you'll see exactly what I'm talking about. Well, I hope you enjoyed this video, despite the many bloopers that I've had, some of the mistakes that I've made. Don't forget to like, comment, share and subscribe. Thank you for watching, and I'll see you in the next video. Bye.